Hello everybody, welcome back to another video, and in this video we'll be looking at the integral from 0 to pi of x squared multiplied by the cosine of 4x. And whenever we have a product of two functions as part of the integrand, we will want to use the integration by parts method. And of course, you can choose to use the traditional UV VDU setup or UDV setup, and then you can go about that. However, I will be using the DI setup, and with the DI setup, it allows you to look at this in a table-based format and take a lot more integrals and derivatives without having to use a lot of variables and a lot of working. So all we need to do is we need to have alternating signs here, starting with a plus, and then we choose something to differentiate and something to integrate. Now, what do we choose to differentiate and integrate? And while there are formulas and abbreviations that help you decide what to choose, they shouldn't be the sole marker, because there are often times where you have to go beyond those rules and see some tricks which are not part of the ordinary rules. So anyways, here we have a fairly simple question where we can see that taking the derivative of x squared will be very beneficial to us, because we know that taking the nth derivative, for instance, say, of a polynomial will eventually result in 0. And we know that one of the markers to stop taking derivatives and integrals in the DI setup is when you reach a 0 in one of the columns, which will mainly be the differentiating column. So here, let's take the derivative of 2x. So derivative of x squared is just going to be 2x, and then derivative of 2x is 2, and then derivative of a constant is 0. So that's good, we can stop now. And of course, we therefore have to integrate cosine of 4x. So how do we integrate the cosine of 4x? So the integral of the cosine of 4x. Well, to do that, we need to just use a simple u sub, where we set u to be 4x. Therefore, du is 4 dx. This should just be a recap. Dx is du by 4. And we see that we can take that 1/4 multiple out. We're integrating cosine of u in the u world, and that's going to give us 1/4 sine u, and u is 4x. So what we see is that we have a general formula where we have the integral of cosine of ax, and dx, that's just going to be 1 over a multiplied by the sine of ax. And the same goes for sine. However, if you're integrating sine of ax, it's going to be negative cosine of ax divided by a, because the derivative of, or the integral of sine is negative cosine. So anyways, here, when integrating the cosine of 4x, we now know that that is 1/4 of sine of 4x. And that is why this can be thought of the reverse chain rule, because we know that if we're differentiating cosine of 4x, we have 4 multiplied by negative sine of 4x. So anyways, here, now taking the integral of this again, well, we have to divide by 4 again. So 1/4 divided by another 1/4, that's 1/16. And then the integral of sine is negative cosine, so we can put the negative cosine there, and we still have the 4x. And now finally, once we've reached a 0, we know that the product of a row is always an integral. However, we know that since this is a 0, whatever we integrate here, whatever we get as the result of the integral here, the product of the integral will be 0 multiplied by some function, which is always 0. So that's why whenever we work out whatever the integral of this is, we can just immediately just take the product of all of the diagonals, and then we should actually be done. So let's just do that. So now we have to take the integral of this. So now we have 1/16 divided by another 1/4. So we have a negative 1 by 64. Integral of cosine is positive sine. And here we just have a 4x still. So now we see what I mean, because here we take the product of all of these diagonals, and we should be done, because this integral that we would traditionally take would just evaluate to 0. And that is why we stop when we have a 0. So that is pretty cool. So all we now need to do is we need to see that the integral of, what was it? It was 0 to pi of x squared cosine of 4x dx is, now this is a 1/4 of x squared sine of 4x. Here we have a minus, so we have a minus, but then this is also a minus, so therefore it becomes a plus. And what we notice is that the constant multiples, we have a 2 multiplied by 1/16, which is 1/8. So we have a plus 1/8 of the 1 plus 1/8 x cosine of 4x. And here we have now finally plus 2 multiplied by negative 1/64. So that plus will turn into a negative because of this, because you're multiplying them. So minus, and then here we have a 2 multiplied by 1/64, which makes it 1/32. And then we have a sine of 4x. However, remember, this all needs to be evaluated from 0 to pi. So let's get started with doing those substitutions. So the first thing that we can see, okay, so let's plug in pi. So this will be equal to 1/4, and then we have so let's make this a much larger bracket. So here we have 1/4 of pi squared, and then we have a sine of 4 times pi, sine of 4 pi, plus 1/8 of pi multiplied by the cosine of 4 pi, and now we subtract 1/32 of the sine of 4 pi. And now what we have is we now have to subtract the fundamental theorem of calculus. We do this result minus plugging in the lower bound. So we know that plugging in 0 into both of these first terms, we have an x squared and an x. Plugging in a 0 into them, that will just result in a 0 as well. And what we have here, so those terms will collapse into a 0. So now we just have 1/32 times the sine of 4 times 0 is 0. Okay, so that's fine. Now let's evaluate this. So first thing we can do, what is the sine of 4 pi? Well, how do we figure that out? Well, we know that that is just a rotation, because we know that the sine of 2 pi will just repeat. So the sine of 2 pi will be the same as sine of 4 pi, sine of 6 pi, or the sine of 0. And we know that the sine of 0 is 0. So this will be equal to 1/4 pi squared times the sine of 4 pi, which is 0. Then we have a plus 1/8 of pi times the cosine of 4 pi. And what is the cosine of 4 pi? Well, the cosine of 4 pi, using the same idea that you can just see that there is a period of 2 pi, we can look at that as being the same thing as the cosine of 0. And what is the cosine of 0? That is 1. So multiplied by 1. Now we have minus 1/32, and then sine of 4 pi, we know once again is 0, so that's just going to collapse to 0. And now here we have a sine of 0, which of course we know is a 0, so we just have to subtract a 0 here. And that, we can put a bracket here, and once we evaluate this, we should be done. So let's just double check to see if we've done everything correctly. Yeah, that should be fine. So what we notice here, this 0 multiplied by anything, that will cancel out. Here we have 0 multiplied by 132, that will cancel. Subtracting 0 doesn't matter. And all that we're left with is a 1/8 of pi. So therefore, we have 1/8 of pi, like so. And this is our final answer. So we can finally see that the integral from 0 to pi of x squared multiplied by the cosine of 4x dx is equal to the 1/8 of pi. And that was pretty cool. Just a recap of what we did. We used the integration by parts method and the DI setup to work out everything. And we saw that taking the derivative of x squared means that we will eventually reach a 0, which is one of the signals which tells us to stop taking the derivatives. And we know that when that happens, we can just take the product of all of the diagonals to be our answer. Then what we see, we still had the bounds of 0 and pi, so we needed to plug in the bounds, of course, from pi, and then subtract the bounds plugging in 0. So that means that you plug in pi into all of the instances where there's an x and subtract a 0 into all of the instances when there's an x. Now what we notice is that the sine of 4 pi, because of the periodicity of the sine and the cosine functions, that is the same thing as the sine of 0 and the cosine of 0. We know that the sine of 0 is 0, the cosine of 0 is 1. So every instance where we had a sine of 0, that entire term would just collapse to 0, because 0 multiplied by anything is 0, and then a cosine of 4 pi would evaluate to 1. So you just have the coefficient as being what that term would evaluate to. So we saw that eventually, and then of course plugging in a 0 into these polynomials, of course, will be a 0 as well, and 0 multiplied by anything is 0. And then we see subtracting the 0 doesn't do anything. Then we have these terms collapsing to 0 as well, and then we're just left with the 1/8 of pi. So therefore, using integration by parts, the DI setup, and some knowledge of our sine and cosine functions, we get 1/8 as our answer. So thank you for watching.